So in this video, we're going to review Sig Fig Operations, specifically how to determine how many significant figures should be in your final answer when you're adding and subtracting quantities or multiplying and dividing. So we're going to go through a bunch of examples because the rules are slightly different whether you're adding, subtracting, and multiplying, dividing. So when you're adding and subtracting, the first thing that I recommend is when you do the operation, line up your decimals, and I've done that with all of the examples on this page, because how you determine how far beyond the decimal your answer needs to be depends on how far your two quantities are. So the one that goes out the least far determines your cutoff, so to speak. So with this 450.1 and 600.25, I need to add these together. I've lined up my decimals, and then what I usually recommend doing is like a dotted line. So I did the dotted line to the right of that 1 in 450.1 because that's going to tell me how far beyond the decimal my final answer will go in terms of how many digits I keep. Now I'm going to actually do the operation on my calculator. So 450.1 plus 600.25, and my calculator tells me 1050.35. So that 5 that's on the right side, that's going to the hundredths place. That's beyond my dotted line. So I need to round to the tenths place. And in the previous video, we went over rules of rounding. So because we got a 5 here, we're going to round up. And our final answer, 1050.4. So then just a note on the number of sig figs we had in each quantity. In the 450, we had 4 sig figs. In the 600.25, we had 5 sig figs. And in our final answer, we had 5 sig figs. But again, we use that dashed line that I drew to determine how far beyond the decimal our answer will actually be. So next example, 0.0570 added to 0.123. So inserting our dashed line would look like this. It's going to go 3 places past the decimal point. Now I'm going to actually add it up on my calculator. So the 0570 plus 0.123, my calculator tells me 0.1800. So that second zero is beyond my dashed line, so I'm not going to keep it. So my final answer is 0.180. So then just to remind ourselves how many sig figs all of these numbers have, the first quantity had 3 sig figs, the second quantity had 3 sig figs, and our final answer happens to also have 3 sig figs. Now, when you actually type this into your calculator will tell you 0.18. So you'd actually need to add another 0. I added them already for this video that I'm recording for you, but your calculator will probably not include those zeros, and you'd have to manually add that 0 in to get to the proper number of sig figs. Next, we have 1,000 with no decimal, just 1,000 plus 1,500.0. So we're going to draw our dotted line like this. So 1,000 on our calculator plus 1500.0, we get 2,500. And I'll go ahead and add in that last 0 just to clarify, but that 0 is again beyond the beyond the dotted line. So we just write 2,500. That first quantity of 1,000 only had 1 sig fig. The second quantity of 1,500.0 actually had 5 sig figs. But our final answer only gets 2 sig figs because these zeros don't count because those are placeholder zeros. Next example, 2.56 and 104.9. So here's where our dotted line will be. And again, with all of these examples, I'm setting it up where I'm lining up the decimal. So I highly recommend you do that with any problem you're doing. Next up, punching it into our calculator. So 2.56 plus 104.9. My calculator tells me 107.46. So that 6 is on the opposite side of the dotted line. We're going to have to round. So since this is greater than 5, we're going to round this 4 up. So our final answer would be 107.5. The 2.56 had 3 sig figs. The 104.9 had 4 sig figs. And our final answer ended up with 4 sig figs. Next example for adding. 7.0 added to 93. So this is how I'm going to draw my dotted line. So 7.0 plus 93, we get 100. So 100.0. But that 0.0 falls on the other side of our line, so we're just going to have it be 100. Now this is an interesting thing where if I just leave it as 100, that implies only 1 sig fig. So sometimes what we might do is just put a decimal right there to tell everyone else that's viewing our work that we actually have and wanted 3 sig figs, which is the correct answer here. Sometimes they may also do it with a bar above or below to indicate that those are significant, or a bar just over the last digit. I personally like the just putting the decimal at the end, because then that keeps all of these digits to be significant. But 3 sig figs, so the 7.0 had 2 sig figs, the 93 had 2 sig figs, and our final answer ends up with 3. Next example for adding, so 47.2 and then 841.435. Here's where the dotted line goes. So now towards our calculators, 47.2 plus 841.435. My calculator tells me 888.635. So we're going to have to round again because we don't care about the 3 and the 5. We need to get rid of those. We need to round to the tens place. This 3 here is smaller than 5, so we're just going to round down, which means our final answer is 888.6. The 470 and the 47.2 had 3 sig figs. The 841.435 that had 6 sig figs, and our final answer has 4 sig figs. Now just a few with subtracting. So 100.0 minus 7. The rules are still the same, adding and subtracting. We're going to draw a little dashed line. 100 minus 7, we get 93. So 93, and I'll be more specific, 0.0, but that 0.0 part, we're just going to toss away, so it's just 93. The 100.0 had 4 sig figs. The 7 only had 1 sig fig, and the 93 has 2 sig figs. Next example, 1000.50 minus 8.1. So this is where my dotted line is going to go. 1000.5 minus 8.1. My calculator tells me 992.4. And I'll put in another 0 just to show that that 0 we're not going to keep. Anything that's on the right side of the dotted line we're not going to keep. So we're just going to round it to 992.4. So the 1000.50, all of those are significant. So this is a 6 sig fig quantity. 8.1 had only 2 sig figs, and 992.4 has 4 sig figs. Next example, 579 minus 47.84. We're going to put our dotted line right here. So calculator time, 579 minus 47.84. We get 531.16. But the 16 ended up on the other side of the dotted line, so we're going to toss that away after considering rounding. We're going to round to this position, the ones place. This digit is less than 5, so we're just going to round to 531. This quantity, the 579, had 3 sig figs. 47.84 had 4 sig figs, and our final answer had 3 sig figs. Last example for multiplying and dividing. 0.0079 minus 0.00342. So this first one has 4 places past the decimal, and the next one's 5 places. So this is where our dotted line is going to go. So calculator 0.0079 minus 0.00342. My calculator tells me 0.00448. So that 8 needs to go away. We only want to keep those 4 places past the decimal. So we're going to need to round, to this location. That 8 is greater than 5, so we're going to round up. So we're going to round to 0.0045. The 0.0079 had 2 sig figs. The 0.00342 had 3 sig figs. And our final answer had 2 sig figs. So one thing that should be obvious is the number of sig figs in your answer did not necessarily immediately tell you how many sig figs, the number of sig figs in the quantities you were adding or subtracting did not immediately tell you how many sig figs were in your final answer. It could have gone up or could have gone down. It depended on where the decimal points lined up. Multiplying and dividing, I think it's maybe a little bit easier, and we'll actually encounter this more often, I think, in our calculations. So multiplying and dividing. So this first example might be something where you're trying to find the volume of something. And we'll go into this later on as we progress through the course, but just to show you how sig figs work, if we were to take 3 lengths and multiply them, we actually get a volume. So let's pretend you were measuring the dimensions of a block or something, and you got 4 centimeters and 8 centimeters and 12 centimeters. And you had to multiply those 3 things to get the volume. This first quantity, 4.0, has 2 sig figs. The next quantity of 8 has only 1 sig fig. And then 12.0 has 3 sig figs. The rule for multiplying and dividing is whichever one has the fewest number of sig figs, that's how many sig figs your answer has. So this 8 centimeters has only 1 sig fig, so our final answer is going to have only 1 sig fig. Now we'll actually calculate it. So 4.0 times 8 times 12.0, my calculator tells me 384. However, I need to round that to just one significant figure. So I need to round it to the hundredths place, which means I'm going to look at the 8, and 8 tells me I want to round up. So our final answer will just be 400. And in terms of units, it would be cubic centimeters, but we're not worrying about the units quite yet. We're just practicing our sig fig rules for this video. So our next example, 35.45 grams per mole. So this is commonly used for molar masses, which we're going to learn about in a future video, so don't worry about it too much, times 2 moles. And you might ask, what is a mole? Well, again, we're going to get to that as we progress through the course, but the point is this calculation is something that you'll commonly come across as we learn about chemistry. But just in terms of the numbers, 35.45 times 2, the 35.45 has 4 sig figs, and the 2.0 has 2 sig figs. So our final answer is going to have 2 sig figs because this one's smaller. So now towards our calculator, we're going to type in 35.45 times 2.0. Our calculator tells us 70.9, but we need to round that to just 2 sig figs. So we need to round to the ones place. We're going to look at the 9, which tells us to round up. So we're going to round to 71. And again, I'm not worrying about the units for this video. I'm just focusing on the numerical values. Next example, 1.50 grams per milliliter times 3 milliliters. Grams per milliliter is the units for density. And one of our first labs, or at least one of the labs we do, is a lab about density, trying to figure out the density of a substance. But let's say you have the density of something, and you also know that you have 3 milliliters of it, and we want to multiply these. 1.50 has 3 sig figs, 3.0 has 2 sig figs, so our final answer is going to have 2 sig figs. So now to our calculator, 1.50 times 3.0. Our calculator tells us 4.5. That answer already has 2 sig figs, so we're good. And that is our answer, 4.5. Again, not worrying about the units. So next is an example where we're dividing. And again, we've got a grams over milliliters, so this would be like you're trying to figure out the density of an unknown object. We measured the mass, we got 10.500. That has 5 sig figs. And then we also measured the volume of that object, and we got 9.43. That has 3 sig figs. So our final answer needs to have 3 sig figs. So now putting this into our calculator, 10.500 divided by 9.43. My calculator gives me quite a lot of digits. I'll write them all down. 1.1134676656. That's a lot of numbers, but we only need 3 sig figs, which means we're only going to round this far, so to the hundredths place beyond the decimal point. So we look at the 3, the digit that comes next. That tells us to round down, so our final answer is going to be 1.11. Our final numerical answer is going to be 1.11. Next example, again, another pretend density example. We've got 15.5 grams was the mass of some object, and we also measured its volume to be 17 milliliters. 15.5 has 3 sig figs, 17 has 2 sig figs, so our final answer needs to have 2 sig figs. According to our calculator, 15.5 divided by 17 is 0.9117647,059. But we only need 2 sig figs. Now this first 0 is a placeholder 0. It doesn't count. It's on the left side of the decimal. So we need to round to just the 9 and the 1. We look at the next digit, however, to see if we round up or down. It's a 1, so we're going to round down. So our final answer is just 0.91. Last example, 3.000 grams, and now we're dividing by a molar mass. Again, don't worry so much about molar mass and that stuff quite yet. That's coming up in the future weeks. But the 3.000 has 4 sig figs. The 12.0 has 3 sig figs. And then if you're concerned about this one, which you should be, I would classify that as having an infinite number of sig figs. It's part of the definition of a molar mass. So molar masses are always so many grams per 1 mole, exactly 1 mole. So we're not going to worry about the one part in terms of limiting our sig figs, just the 3.000 and the 12.0. So since this one had fewer number of sig figs, our final answer needs to have 3 sig figs. So 3.000 divided by 12.0. Our calculator tells us 0.25. Now 0.25 by itself as written has only 2 sig figs, but we need to have 3, which means we're going to have to add a 0 to our answer so that our final answer actually has 3 sig figs. So again, this first 0 doesn't count. That's a placeholder 0, but these other 0, or the other digits, including the 0 we just added, those all count. So we get 3 sig figs for our final answer.